Hey students, I just wanted to make a quick video on arcs and sectors of circles. Specifically, we'll talk about arc measure, arc length, and the area of a sector. For those of you that don't think circles have applications outside of geometry, this is from a video game I think called Color Switch. Anyway, so let's see, what do we have? Here's circle A. And a circle is always named by its center, so this is circle A. And we have a bunch of radii that I've drawn here. So we have J, E, T, and S are points on the circle. So sometimes they'll give you circle problems as ratios, so you have to figure out the measure of the arcs based on some sort of ratio problem. And so this shouldn't be too bad. We've done some other ratio problems in the past. So if we have the measure of arc JE, and remember that's going to be measured in degrees, it's not the length of this arc, it's the measure. So it's, if we think about the amount of turn of the circle. So we have JE, ET, TS, and SJ. And they're in a ratio of 4 to 2 to 6 to 8. All right. So when I see that, I'm just going to go ahead and label these arcs of 4, 2, 6, and 8. So when I see a ratio problem, what I like to do is I just make it into an algebra problem. So we have 4x, 2x, 6x, and 8x. So ratios, remember, are just parts problems. So we have 4 parts, 2 parts, 6 parts, and 8 parts. How many parts do we have in all? Well, if we add those up, we have 4, 6, 6 plus 6 is 12, plus 8 is 20. So there's 20 parts here. Right? But what is each part? Well, 4x plus 2x plus 6x plus 8x, this equals 360 degrees, right? So I know all of these parts have to add up to 360. So what does each part equal? Well, each part equals 18 degrees. So now that I know that, I can substitute in 18 degrees for each of these, and I'll get 36 degrees, 108 degrees, 144 degrees, and 72 degrees. So that's arc measure. And remember, a central angle, so say for example, say this angle here, right here, EAJ, equals the arc measure. So this would also be 72 degrees. So that's one example, and let's go through a couple others. All right, so let's take a look at this one. So we found out that the central angle is 144 degrees, right? We've solved that in the last problem. And we know that because of the arc measure is 144 degrees. So a lot of times they'll ask you what the arc length is. So if I had to walk along this, how long is this? So not the measure in terms of degrees, the amount of turn, but how long is that arc? So we need more information. They haven't given us enough information here. So I'm just going to go ahead and make this up and say, let's say the circumference is 10 pi, right? So that is the total circumference of this circle. And a lot of times they're going to give you it in terms of pi. So pi is just a number, right? Pi is just 3.1415926 and so forth. And that number represents actually the ratio of the circumference to the diameter of any circle. So whatever this circumference is, if you divide it by the diameter, then you can figure out what pi is. It's 3.1415. So if this circumference is 10 pi, then what is the arc length of SJ? Well, SJ is just a fraction of the entire circle, and that fraction is based on these degrees here. So I know the entire circle is 360 degrees, right? So what piece of that is this? Well, it's just going to be the total circumference times the amount of degrees of this arc divided by 360. That's my fraction. So when I multiply all this out, I get SJ is 4 pi. And so I can multiply that out on my calculator. It's 3.1415 times 926 times 4, which is going to be 12 point something. So that's the length of this arc. Let's take a look at area, sector area. Okay, so let's talk about area of a sector. Now, if we know the area of a circle, we can figure out the area of a sector. But in this circle here, we don't know what the radius of this circle is, and they like to do that a lot, especially on SAT problems, where they'll give you some other information. You have to actually solve for the radius first, and then you have to solve for the area. So remember in the previous problem, we said that the circumference was 10 pi. So they would have to give you some sort of information like that. So let's say that the circumference of this circle is still 10 pi. We can now solve for the radius, because we know the circumference of any circle is 2 pi r. So let's go ahead and solve for the radius. So I know this circumference is 10 pi. If I set 10 pi equal to 2 pi r, I divide both sides by 2 pi, then all of a sudden I know the radius has to be 5. That makes sense, right? So if the whole circumference is 2 pi r, then 2 times 5 is 10, so that's 10 pi. Okay, but now I need to figure out the area. Now area is pi r squared, so the area of the entire circle would be pi r squared, which in this case would be pi times 5 squared, which is 25 pi. All right, so that's 25 times 3.1415926. So, but I want the area of just this shaded sector, this slice of pi. So I'm going to multiply the entire area by this fraction, this 72 over 360. And that's 72 degrees of the entire 360. So I'm just going to replace that r with 5, and that's going to give me pi times 5 squared. And if I multiply this all out, and I plug it into my calculator, I get that the area of this sector happens to be 5 pi. So this sector is actually just 1/5 of the entire circle, right? Because the entire circle is 25 pi. This happens to be 5 pi. So I hope this helps try and clear up some of these differences between arc measure, arc length, and area of a sector. And also we threw in some ratio problems in there as well. So there's a lot on this video. Please let me know if you have any questions, and I'll talk to you soon. Thanks for watching.